So, hi everyone. Okay, how are you guys doing today?
Good.
Do you guys know what we are going to do today?
No.
So, for this subject, we are going to the chapter 5, the fundamental of logic. In this chapter, we are going to cover 4 subtopics, which is truth table, law of logic, arguments, and rules of inference. So, are you guys ready?
Ready.
Fundamental of logic. Fundamental of logic refer to the basic principles and concepts that underpin logical reasoning and critical thinking. Logic is the study of reasoning and argumentation. Logic also revolves around reasoning and drawing conclusions based on premises. It is also a foundational tool for mathematical proof and problem solving. Did you know we can apply the application of logic in real life such as in legal reasoning? Lawyers and judges often use logical reasoning to construct arguments, analyze evidence, and apply legal principles. Other than that, there are also in the games such as Sudoku and chess. Solving Sudoku involves deductive reasoning. You use constraints to deduce where the number should be placed on the grid. While chess, players use logical thinking to plan moves, predict opponent strategies, and evaluate potential outcomes. Before we dive deeper, let me briefly explain the subtopic covered in this chapter. Firstly, we have statements. A statement or a proposition is a declarative sentence that is either be true or false but not both. The true value of a statement is true if it is a true proposition and false if it is a false proposition. It also can be presented by a variable such as x, y, z, and others. The variables that represent the statement are called propositional variables. In a statement, we must declare something, not asking a question, and must be clear and unambiguous. For example, number 1, 2 plus 2 is equal to 4. This is a statement. Number 2, water is essential for human survival. This is also a statement. Number 3, where is the library? Because it asking a question, therefore this is not a statement. Number 4, the square root of 4 is 5. This is not true, therefore this is not a statement. Secondly, we have logical connective. Logical connective is a few primary statements that can be combined to form a single compound statement. A compound statement is a new statement formed by existing statement and logical operators. In the table, we have 5 logical operators. First is conjunction and. Second, disjunction or. Third, negation not. Fourth, implication if then, and fifth, biconditional if and only if. This is example statement. Firstly, it is raining and it is cold. The keyword is and, therefore the answer will be P conjunction Q. Second, I will go to supermarket or I will do my homework. The keyword is or, therefore the answer will be P disjunction Q. Third, I will go to the Shah birthday party if and only if I finish my homework. The keyword is if and only if. Therefore, the answer will be P biconditional Q. Next, we have truth table. Truth table can be used to evaluate statement. It determines the validity of the truth of a compound statement. A compound statement that is true for all possible value is called tautology, while a statement that always false is called contradiction, and a statement that can be either true or false depends on truth value is called contingency. Then we have logical equivalence truth table. Logical equivalence occurs when two statements have the same truth value. For example, with P biconditional Q, the column containing P and Q will have identical truth value. For this example, negation P and P conditional Q have the same truth value. Therefore, it's equivalence. Other than that, we also have logical equivalence law of logic. Other than using truth table, two statements can be shown as logical equivalence by using law of logic. In the table, these are all the laws that we can use. We can also use additional conditional statements, such as converse, contrapositive, and inverse. There are also switching network. A switching network or circuit can be divided into two types, which are serial and parallel. The logical expression can be used to represent the network. For serial network, the connector N is used, and for parallel network, the connector R is used. This is the example. Then we have arguments. An argument is a set of two or more sentences or beliefs. It is a collection of statements or propositions, some of which are intended to provide support or evidence for others. One of the sentences or belief is the conclusion, the rest are premises. This is the set of statements that assume to be true, while the conclusion the statement that is derived from the premises. A logical argument is valid if the conclusion logically follows from the premises. This is the structure and example of arguments. Example statement: I'll go buy a flower, or I'll go to Munira's house. I won't go to Munira's house, therefore I'll go buy a flower. P will be I'll go buy a flower, and Q will be I'll go to Munira's house. The premise 1 will be P or Q, and premise 2 negation Q. The conclusion will be P. Therefore, the arguments will be P or Q, and Q negation Q implies P. Lastly, rules of inference. Rules of inference are logical rules that help us draw valid conclusions from given premises. They are like step-by-step methods used to build arguments or solve problems logically. These are some of commonly used rules of inference. There are modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism, addition, simplification, and conjunctions.
So, do you guys understand?
Oh, now we understand.
Here's the task. Create a video presentation about application of logic in real life. In a group, the presentation should last between 15 to 30 minutes. Okay, start.
A few moments later.
How do we apply the fundamentals of logic in real life? Maybe we can use method such as maybe we can use rain. Oh, if it's raining, then the ground will be wet. If it's not raining, then the weather must be dry.
Here is a concept of arguments. Premises. In an argument, premises are the statements that provide reasons or evidence to support a conclusion. Conclusion. The conclusion is the statement that is being supported or proven by the premises. The conclusion is logically follows from the premises. The premises are intended to provide a foundation for the conclusion, showing that the conclusion is true. And next, we have concept of rules of inference. Rules of inference are logical principles used to derive conclusions from given premises. In this video, we use two types rules of inference, which is hypothetical syllogism and modus tollens. Hypothetical syllogism, a form of reasoning that combines two conditional statements to derive a third conditional statement. Modus tollens is a fundamental rule of inference used in logical reasoning. It allows you to conclude that the antecedent P of a conditional statement is false if the consequent Q is also false. So, from the video earlier, here is our statement of argument. If it's raining, then the ground will be wet. If the ground is wet, then the weather must not be dry. The weather must be dry, therefore it's not raining. It's supposed to be three statements, P, Q, and R, where P, it's raining, Q, the ground is wet, and R, the weather must be dry.
Look, it's raining. The ground is wet. The ground is wet. Then the weather must not be dry. The weather must be dry.
Therefore, it's not raining.
Here is the solution that we can do from the video just now. First, we will describe some symbolic statements which are involved with these simple statements. Premise 1 is P implication Q. Premise 2 is Q implication R. premise 3 is R. Then the conclusion will be not P. So the arguments P implication Q and Q implication not R and R, then the conclusion will be not P. Now we can determine whether the arguments are valid or not by using truth table. First, to test the validity of the arguments, I will create a truth table. Since we create a truth table, we have to create three variables, which is P, Q, R. In the first column of P is truth, 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 false, 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 false. For the second column, which is Q, truth, truth, false, false, truth, truth, false, false. For the third column, which is variable R, truth, false, truth, false, truth, false, truth, false. Since we have not P and not R in the statements, we can write not P, which is false, 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 truth, 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 truth. For the fifth column, not R, which is false, truth, false, truth, false, truth, false, truth. Next, P implication Q, truth, truth, false, false, truth, 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 truth. Then the Q implication not R, false, truth, 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 false, truth, truth, truth. And then we need to combine, which is P implication Q and Q implication not R, which is false, truth, false, 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 truth, truth, truth. And then the combination just now, we need to combine with R, which is false, 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 true, false. And then for the last column will be the implications not P, which is truth, 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 truth. We can see here from the last column contains only truths. Therefore, the argument is valid and tautology.
From the symbolic that we created just now, which is P implication Q, Q implication not R, and R, we can also validate the conclusion using rules of inference. So, we have to simplify it until we get the conclusion, which is not P. For the first step, we need to create a table and label it as premise 1, premise 2, and premise 3. As you can see, premise 1 and premise 2 can be simplified by using hypothetical syllogism. And now, we get P implication not R as the result, and we can label it as premise 4. For the next steps, from premise 3 and premise 4, we can simplify by using modus tollens. And now, we get not P as the conclusion. For the conclusion that we get from this statement is not P, which is it's not raining. Finally, the conclusion for this video is Logic plays a vital role in helping us think clearly, make sound arguments, and solve problems effectively in both real life and mathematics. Logic guides our decisions, helps us resolve conflicts, and improves our planning. Logic is important in fields like law, where logical reasoning ensures that arguments are structured, evidence is evaluated systematically, and conclusions are reached fairly. Thank you!